Hey guys, has this started already? I can't hear anything.
Got it started. Hello, can we continue now?
Yeah, we can hear you.
Hello everyone, welcome to PM Networking. This webinar is on troubleshooting course and Amit sir is the trainer who will be taking. Amit sir, are you there?
Yes, Arunya.
Okay sir, we can continue now.
Sure, thank you. Hi, everyone. Very good evening. I think we can start now. It's almost 15 minutes now, 8:15. So first of all, I'll share my screen and then we'll start, guys. I hope my screen is visible now to everyone. Okay, great. So let's start without any further delay. It's already 15 minutes past. So guys, as all of you know, this webinar is for real time enterprise troubleshooting. So guys, first of all, I have a very humble request. Please mute yourself. If you need to ask something, you can raise your hand and then we'll allow you some time, okay, to ask the questions. But till then, please mute your mic. Thank you. So this course is about real-time enterprise troubleshooting. Before that, guys, I'm sure that if someone is joining this course, you might have some experience in the network, or you have at least done your CCNA, CCNP, and then you are already working in the organizations, because this course is for not for the freshers, first of all, because in this course we will be learning that how to troubleshoot a problem in a network, or how we can start the process so that we can find out the actual cause of the problem and then we can fix it. So this whole course is dedicated to troubleshooting only. This whole course is dedicated to troubleshooting only. So if may I ask you a very simple question, or not question, let's say if we talk about just troubleshooting. So as its name suggests, right, troubleshooting. So first of all, there's some trouble in the network. There's some trouble in the network and we have to find it out. We have to find the problem and then we have to fix it. So basically troubleshooting or network troubleshooting is what? It is a process of responding to a problem, diagnosing the underlying cause of problem, and resolving the problem. And resolving the problem. But before starting with this, we must know that how a network is working. So for this course, there are simple, very basic prerequisites. You're not supposed to be master of any specific technology, but at least you must know few things about the network, that how a particular network is working or how it is supposed to work. And our focus is on enterprise network here specifically, because in CCNA we learn about types of network. we learn about types of network. And in those type of network, we start with local area network. So in Cisco terms, this local area network is also known as enterprise network, guys. We have wide area network, and then we have data center network. These are three major type of networks. Otherwise, we have like personal area network, metropolitan area network, but these are some specific, or you can say most specific types of network we have: local area network, wide area network, and data center network. So they serve different purpose, they use different kind of devices, they use different services, or you can say network appliances. Let's say in local area network we are using catalyst switches. In local area network or in the enterprise network we are using the catalyst switches if we work on Cisco appliances. So we have catalyst switches, and we have iOS routers. In wide area network we use most of the time we are using routers, and then we are using different set of protocols, like we are using ISIS, MPLS, and a lot other type of protocols we are running in wide area network. And data center network is entirely different, right? Because data center network, first of all, in data center network we have specific appliances or switches known as nexus switches. known as nexus switches. Those nexus switches are very powerful, and they are specifically designed for data center network. And again, we use different type of protocols. We use different type of protocol in data center network also. But our focus will be on local area network, or you can call it enterprise network. You can call it enterprise network. So then we talk about again troubleshooting. So in enterprise network, first of all, we use major two types of devices. We use router, we use switches. As well as in enterprise network, we have wireless network. So we might see a wireless access point also, because we are providing connectivity to the wireless appliances as well. And last but not the least, we have endpoints. Last but not the least, we have the endpoints. You have router to provide the routing capabilities. Then we have switches to provide connectivity to multiple endpoints. Then we have the access point for wireless connectivity. And we are having endpoints then. Now in endpoints, we have examples, right? Like you have a desktop, you can have a laptop, then we can have IP phone, mobile phones, and a lot of different type of devices we have in here as an endpoints. Then access points, which is routers. Okay guys, give me some examples of layer 2 protocols and layer 3 protocols in the chat box. The layer 2 protocols we run in local area network or in enterprise network, as well as layer 3 protocols. Give me a few examples in the chat box. Chat box is open. You guys can put your answer in the chat box, guys. Layer 2 protocols which we use in local area network, and layer 3 protocols. Yes. OSPF, RIP, EIGRP, very good. STP, VTP, yes, great. OSPF, EIGRP, yes. That's all. OSPF, EIGRP, ISIS, BGP, great. HSRP, very good. VLANs, absolutely right. VRRP, ZLBP. That's great, guys. That's great. So we use a lot of different type of protocols here, right? We use layer 2 protocols, like we have spanning tree protocol here, STP, we have VTP. In layer 3 protocols, we use OSPF, EIGRP, BGP, ISIS, HSRP, VRRP, and all. There are a lot of protocols we have in local area network or enterprise network. We use layer 2 protocols, we use layer 3 protocols also. But here our agenda is to discuss about the troubleshooting of a network. Why we are talking about all these things then? Like Ether channel, you said, right? VXLAN. VXLAN is used in data center networks. VXLAN EVPN is used in data center network. We don't use VXLAN EVPN in enterprise networks. Then we have CDP, LLDP, right? We got comment in the chat box also. ARP, resolution protocols, TCP IP. So all of these protocols we have. But again, we want to focus on troubleshooting. We want to focus on troubleshooting. So whenever we have any problem in the network, so first of all, guys, we don't have to wish for it, okay? Because if you want to be good at troubleshooting, there's a simple thing. If you want to be good at troubleshooting, your network must have the problems, and you'll keep fixing them. So it is all about experience, but we must know some techniques, and you can say we must have some process to troubleshoot a network. We must have a structured and systematic maintenance approach. So if you want to be good at troubleshooting, you always have to work on troubleshootings of your network. But again, it depends. If your network has some problems, then you'll fix the things, right? Although there is no right or wrong way to troubleshoot a network, but we have to find a more efficient and effective way to troubleshoot that all experienced troubleshooters follow. So that's why we are having this discussion here. That's why we are talking about this troubleshooting. Now, whenever we troubleshoot a network, we always see few steps there, right? First of all, what do we have, guys? First of all, someone will report a problem. If a problem is not reported, right, then what will troubleshoot? Then, if problem is reported, then you'll start problem diagnosis. After diagnosing the problem, you will look for the problem resolution. Problem report, problem diagnosis, problem resolution. So we have first of all, someone will report the problem that I'm facing this problem. I'm facing this problem. Once they report this problem, then you will start looking for the diagnosis, that what could be the issue. Then you will try to find the resolution. You'll try to find the resolution. So we always have to follow a approach. Now, if you look at it from OSI model and TCP IP model, guys, I'm sure that all of you guys are aware of these two models, OSI model and TCP IP model. So in OSI model, how many layers do we have? We have 7 layers, right? We have application layer. Then we have the presentation layer, session layer, transport, network, data link, and physical. Likewise, we have 4 layers in TCP IP model, or nowadays we have 5 layers in the updated TCP IP model. What is the advantage of having all these layers? Because if you look at OSI model or TCP IP model, why do we have these models? So that we can provide communication between different vendors. We can provide communication between two different vendor machines. That's why we have designed these models. So they can give us some standard protocols, and using those protocols, we can provide communication between different machines, right? But then what we did, we have divided the whole process into 7 layers also. How does this 7 layer helps, guys? This 7 layer helps very well in understanding the whole process, as well as they also give us a structured approach. They also give us a structured approach whenever we start troubleshooting the network. Whenever we start troubleshooting the whole network. Whenever we start troubleshooting the whole network. Again, in that case, it helps us to have a systematic approach or to look at the problem from the structured layer as well. That okay, we must check the physical cable first. If the physical cable is up and running, then it's great. Otherwise, there's a problem in the cable. So we'll fix the physical connectivity first. Then you can go for the IP and all. Naveen Prasant has raised a hand. Yes, please, Naveen.
Sir, what is the difference between OSI model and the TCP model? TCP IP model. Where we in OSI is a reference model, but real time we are using only TCP ICP model, correct?
On our machines, TCP IP model is deployed.
Okay. It is
Then,
inbuilt deployed, correct?
yeah,
So
it's
if you buy,
already deployed in the operating system. As a network engineer, we don't have any control over it that we are going to deploy OSI or TCP IP model. It's
operating
already on.
system.
Yes.
Okay, sir. Okay.
Even if we capture the packets in Wireshark, you will just see 5 layers. You'll never see 7 layers. You'll never see presentation or session layers in a tool known as Wireshark also, because our machines are using TCP IP model. Okay.
Okay, okay, sir. Thank you, sir.
You're welcome. Now, once the problem is reported, guys, we always start looking for some data so that we can have some information related to the problem. So first of all, someone has reported the problem. So you'll go step by step. You'll go by step by step. First of all, you can do what? Again, step one was a problem report, right? Once someone report the problem, then we'll start collecting the information, because you can't troubleshoot the network directly until unless you have some information at least. You'll ask them, okay, what? Show me your packet capture, show me the speed and all. If you're facing issues related to the speed, then you can examine the collected information. That's why in real-time network, you always see that collecting the system logs is very important. Connecting the system logs is very important because using those logs, we can examine the problem. Then you have step number 4, eliminate potential causes. Let's say a host is not able to access the internet. What is the first thing we are going to do? If there's a query that a host is not getting the internet access, so we always look at the host first. We'll not blame our network directly, because in network we have hundred of switches, let's say, or we have bunch of routers. So propose an hypothesis, right? Then verify the hypothesis that okay, this could be the problem, and then we can fix it. After that, you can go with step number 7, problem resolution. And problem resolution is not the only thing, guys. At the last, you have to prepare the documentation also, because there are two lives. Okay, first is you start learning as a student and you are working on packet tracer. So in packet tracer tool, you might build a bigger topology, then you have a problem. You fix the problem, either you remove or add new devices. But in real time network, whenever you fix a problem, you have to provide the proper documentation also. And sometimes customer will ask you, not sometimes but most of the time, the client or the customer will ask you, okay, you have executed this command, why? What was the reason to deploy this particular command? What is the impact of it? Is it going to affect my other type of traffic or not? Is it a fixed, it is a permanent fix, or it is just a temporary fix? So there's a lot of questions from the customer as well. It is not just okay, you fix it and that's done. No, you have to provide the proper documentation also, that this was the problem, this is the solution we have implemented, these are the commands executed, and that's how we come to this conclusion to execute these commands. So customer can ask you all these thing. So that's why proper documentation is also very important when you start troubleshooting the network as a network engineer. As a network engineer, like I was asking you a question, right? Or we were having a simple issue. Let's say we have a network, and in that network we have a host who is not able to access internet, who is not able to access internet. Then what we will do first? What we'll do the first thing, guys? You can put it in the chat box. Just your imagine, whatever you think, what we can do. If we are not able to access internet as a user, what could be the problem? Let's say we have this topology, right? We have simple switch. Sorry, you have users, then you have a switch. We have another switch. Let's say we have a router, and router is connected to internet service provider. And then there's a user who is not able to access the internet. Let's say we have a PC1, we have PC2, we have PC3. We have to check IP is configured or not. Check default gateway is configured in the host or not. Very good, guys. Very good. So first of all, what we will do, first we can go for the physical connectivity. First we can go for the physical connectivity, right? If you have access of that machines, like if there's a person who is not able to access the internet, you'll say, okay, show me your PC. So if you'll look at the PC and you see that the Ethernet cable, there's a cross sign, right? There's a cross sign. So in this cross sign, you notice that, okay, physical cable is not connected. And if you're giving Wi-Fi access, let's say, instead of Ethernet cable, you are giving Wi-Fi access. In that case, you will look for the Wi-Fi that, okay, Wi-Fi must be connected. If Wi-Fi must connected or the Ethernet connectivity, we selected this, right? After that, as you have mentioned in the chat box, IP configuration. You'll check that this user is getting an IP address or not. Because as you know, guys, in real-time devices or in appliances, this in the network, we have two types of IPs. We have manual IP configuration, manual IP, or we have the dynamic IP. So in case of dynamic IP address, we are using a server known as DHCP. And most of the time, in case of 99%, the end users are using DHCP server. We are using dynamic IP addresses in real-time network. So we'll check the user is getting an IP address or not. The user must be getting a valid IP address. Let's say in this case, in this scenario, I'm using Wi-Fi adapter. So if I go to the details, I notice here that we have an IPv4 address 192.168.31.234. Sometimes you get an IP address from DHCP, but guys, in DHCP also, you'll go this tab, you notice, okay, there's an IP address, but the IP address look like this 169.254.10.10, and subnet mask is 255.255.255.0. So you'll check the IP address, but you see the IP address look like this. Is there any problem in this IP, guys? Is there any problem in this IP address?
No, sir, it is Aviva network, I think. 169.254. If DSCP fails, Aviva will take this. But we
Yes,
cannot
very
able
good.
to connect.
This is an APIPA address, automatic private IP address assignment. So you look at the IP, it's okay, there's an IP address, so no problem in the IP, but you have to look closely, right? You might be getting IP address from the DHCP. You'll say, okay, DHCP mode is set. And if the DHCP is mode set, we are getting an IP address. Good, we are great. But still, you have to check what is the IP address exactly. If you see an IP address like this 169.254.10.10, so this is an APIPA IP address and this is not valid. this is an APIPA IP address and this is not a valid address. It can be used for local area communication only, but you can't use it for internet access, or you can't use it for inter-network communication. So you look for the IP. You look for the IP. Then IP configuration is good. We find that, okay, correct IP address is there. We start using ping. Use ping and traceroute, let's say. In this case, we can use ping and traceroute. Very simple, because we are following very simple thing. Because this is, we are looking it from the host perspective. We could have a problem on the routers also. We can have a problem on the switches also. We might have a loop, but first of all, we'll make sure that from the host side everything is correct. So you can start using ping and traceroute. First thing you can do, what you can ping the default gateway IP address. If this PC is reachable to its default gateway, seems good that, okay, traffic is being forwarded to the default gateway, at least to this router. And I am very sure all of you guys already know what is the importance of a default gateway. What is the importance of a default gateway to a host? I'm sure all of you guys know this. Just put yes or no in the chat box. I hope everybody know, right, what is a default gateway, or what is the importance of a default gateway. Yes, okay. So most of you guys know the default gateway, right? So default gateway act as a parent for the end user, because end user does not know how to reach to different networks. End user does not know how to reach to different network. So end user always forward traffic to the default gateway. So default gateway is going to help to forward traffic to different networks. So I'll start checking the ping and trace route, and using this ping and trace route, we can see, okay, our device is reachable to the default gateway. So till that point, there is no problem. Till that point, we don't have any problem in the network. Then there's a very important thing in network known as DNS server. Most of the time, guys, you see that problems are related to DNS, and we'll discuss about DNS in our regular classes also. This is a webinar only, so we can't cover each and every part, right? This is just a, you can say, a webinar where we'll discuss what we are going to cover in this troubleshooting course. But yes, DNS is very important component in our real-time network, because if DNS is not working, then there would always be a problem. Whenever we access a website, or whenever we put a URL in the machine, let's say if I put a URL here, www.google.com. So the first thing my device is going to do is, first thing my device is going to send a DNS query. And if DNS is not resolved, will not get the IP address of this Google server. And if the IP address of the Google server is missing, then again, you can't generate the actual HTTPS packets. And your host will say, I'm not able to reach this website. Or it could be true for any website. So that's why DNS is very important. In machines also, we can use DNS to find out the problem. And there's a command in Windows machine, guys, nslookup. Let's see if I say nslookup.www.google.com. So I verify, okay, I'm getting IP address 142.250.193.68. And there's a IPv6 address also. So it means that DNS is working perfectly fine for this particular website. So if someone is saying that I'm not able to access this particular website, you can check the NS lookup also, that DNS is working or not. If DNS is working properly, we are getting an IP address in the response. Great. There's no problem with the DNS. There's no problem with the DNS in that case. But we have to look for this. We have to check that DNS is also very important, and we can't skip this part, or we can't avoid it. Then you see, okay, traffic is okay, physical connectivity is okay, IP configuration, traffic is going till the router. If you have a firewall in between, let's say in the network, this firewall might be blocking the traffic. So as an enterprise engineer, you are supposed to provide or forward the traffic till the router, and you have to make sure that this router is also sending traffic towards the firewall. But if it is not passing through the firewall, you can't fix it. Then you have to contact the security team. You have to say, okay, my host is sending traffic to the firewall, but firewall is not forwarding it further. Then the security team will look into this and they'll check what is the problem with this firewall, why the traffic is blocked. You might be trying to access a blocked website, a URL which is blocked on the firewall. You might be trying to access that URL. That could also be a possibility, but we can't come to that conclusion directly. We have to find out the rest of the problems as well. We have to find out the rest of the problems as well, guys. So there's no right or wrong method for troubleshooting. It always depends on you, but you must look for systematic approach. You must look for a structured design. Even, in not just in real time networks, I have seen people struggling with packet tracer tool also. Let's say if you talk about a packet tracer, normal scenario, nowadays we are not having any problem with this scenario, but there's a simple problem sometimes. This is a router, this is a switch, this is a host. So as you know that there are different type of devices, so in between different type of devices you need to connect straight through cable, but sometimes people connect crossover cable. They've made everything right, configuration is also right, but the problem is the link will not come up. This is very simple problem. Instead of connecting the straight through cable, you have connected a crossover cable. Nowadays we don't have this problem in the latest operating system because we have a auto MDIX feature, and because of this you don't need to be worried about crossover cable or straight through cable anymore. Crossover cable or straight through cable anymore, because nowadays we have a standard cable. So if you connect it between router and router, it will work as a crossover cable. If you connect it between router and switch, it will work as a straight through cable. So now we have this auto MDIX feature, but this could be a simple problem in the network, right? So we always have to go with these kind of steps or information, right? Collect information. Now, how you collect the information? How you collect the information, guys? Any guesses? I find out the problem. Someone reported that this is the problem. I have to collect the information. How I'll collect the information? What could be the source of information in that case? Okay, so we can collect information. Let's say, okay, you said Wireshark. Very good. So because your typical problem reports, sometimes we have sufficient information is not there to find out the exact reason. So you can do what? You can collect the information using what? Using network monitoring tools. This is like we have SolarWind, right? So from SolarWind, there's a tool, SolarWind NPM, Network Performance Monitor. You have tools like there's another vendor known as PRTZ. So from PRTZ, you might have a network monitoring tool. You can use Wireshark. And for Wi-Fi also, we have some tools, right? You have SolarWind, Network Performance Monitor. You can have PRTZ Network Monitor, Wireshark, or you can have Wi-Fi Explorer. Likewise, we have a lot of network monitoring tools. Using that network monitoring tools, we can collect the information, or you can talk to the impacted users that what kind of problems exactly they are facing. Okay, they'll say, okay, I'm able to access this URL, but I'm not able to access another URL. So it might be the problem with the URL blocking. Sometimes they say, okay, when we download something, we face latency, but in uploading, we don't face any problem. So you see, there's a thousands of problems in the network. There are different problems. You can't have an exact solution for all the problems. But first, you have to look for the information. What kind of information you can collect, and using that information, we'll try to build a theory, and then we'll see, okay, what could be done. Please mute your mic, Abhijit. Thank you. After you collect the information, then you can start examining it, like we said here. After collecting the sufficient information about a problem, then you have to examine it, and on the behalf of that examination, you have to make a conclusion, or you can find out that this could be the potential causes. So based on the troubleshooter knowledge of the network and the interrogation with the collected information, you can start eliminating the potential causes from the problem. But this is not a packet tracer, or this is not a GNSA or event, you guys. In real-time network, if you want to make even a very simple change, you need permission. You need permission from the your manager or your senior IT head. Even in real-time networks, we also deploy what? We also deploy RBAC, known as role-based access control. We have RBAC, known as role-based access control. So as a admin, if you are working in the company, but you might not have the full permission to make any changes. Even if you find out the problem, sometimes you'll say, okay, I can't fix it. You might not have that privilege because of role-based access control. So after the troubleshooting, eliminate multiple potential causes for the problem. Then you have to find out the exact problem, and then you have to give a theory also. And then you must be sure about it that, okay, we'll implement this. You must be sure about the impact of an individual commands which you are running on the networking device. So if you are sure about it, then you can go with it. And in bigger companies, they also give you options or resources, like there might be a spare server where you have the labs ready, and on those labs you can just practice it. You can practice the impact of a command. Once you practice the impact of a command, once you're sure about it, then you can just go and implement it in the real network. Okay, so we could have a different type of problems. So first you have to clear understanding of the issue. You might need to determine who is responsible for working on the hardware or software, because sometimes this might not be your problem. This might not be your problem. It is like having a simple concept. If you have a car, right, might be there's a problem in the car, there's a problem with the AC, air conditioner. You go to the mechanic, but the mechanic is mastering engines, right? So he'll say, okay, do you have any problem with the engines? No. If the problem is not with the engines, then they'll say, okay, you must go to this mechanic, AC mechanic. He'll fix it. If you have some problem with, let's say, the light or brake, then you might have different mechanic. So it depends. In a car, you see there's 100 of components, right? Sometimes if you are a mechanic for the engine, you can't fix every problem in the car. You can't change the windshield. You can't change the music system, let's say. You don't have anything related to the seats. Might be there's a problem, right? So that's why we have to make sure that even if you're responsible for it or not, That's also a very you can say good thing to know that this is in your scope or not. So like we were talking about it here. If you see that packet is going up to this router and this router is also sending it to the firewall, then you can't do anything here. Then you can't do much about it. Okay, guys. So I hope it makes sense till now. Any challenge, any question you guys have, please you can put it in the chat box or you can unmute yourself and you can ask. Hello. Any question till now, guys? Do we have anything in the chat box? What is mechanism behind the ping and trace route, sir? So behind the ping and trace route, there's a very interesting protocol known as ICMP. So we'll be talking about it because ICMP and trace route, you can say they are the lifesaver in network. ICMP stands for Internet Control Message Protocol. So when we say ping is not a protocol in itself. Ping is dependent on ICMP. Likewise, in the Windows machine, you use a traceroute command. But in our routers and switches, we have a traceroute command to trace the path. So again, behind the traceroute, we are using UDP and ICMP both. And there is a very important component known as TTL. You might have heard of it, time to live. Because guys, in this particular class, when we start with this troubleshooting, I'm starting with one thing first. I'll be starting with headers. I'll not be going directly to the network devices and all, but I will be starting with headers first. We'll talk about TCP header. We'll talk about UDP header. And as well as we'll talk about IP and Ethernet headers, guys. Because the information inside this header is very, very important. Very, very important. Let's say right now I'm having a Wi-Fi connection. So if I go to my Wireshark application, in the Wireshark application, which I've installed in my laptop, I can capture the Wi-Fi adapter. And if I capture the Wi-Fi adapter, I see a lot of traffic is going in the background, UDP traffic. Because right now we are having Google Meet. And in this case, we have live traffic, right? So Google Meet is using UDP as a transport protocol. If I open one of the packet, you see the packet is encapsulated. By the way, packet is encrypted. We can't see what it is or what's the message because of the encryption. But if you look at this UDP, UDP is carrying some information: source port, destination port, length, payload, checksum. What does it means? Then UDP is encapsulated with IP, and IP also having a lot of information. So again, we'll discuss what it is. What is the meaning of this payload length, next stop header, hope limit, source address, destination address. In this case, you have IPv6, but you might have IPv6, IPv4 also. Let's say we have some payload on IPv4 basis as well. Let's say there's a traffic. This is IPv4. So in IPv4 also we have IPv4 header. And in this header, we have a lot of information, which is very, very important to understand. If you want to troubleshoot a problem, guys, if you don't understand these values, then it is going to be very difficult. And you will see most of the time, you look at these headers and these Wireshark captures to find out a problem. This tells a lot about the situation of the network. So it is very important. That's why we will be starting with headers first. We'll be talking about TCP header, UDP header, IP header, Ethernet header. Then we'll talk about routing protocols, switching protocols, what could be the problems in there, right? And in last, we'll see some Windows also, because as a network engineer, you don't deal with the Windows machines, but having some knowledge about the Windows, having knowledge of basic Windows command line is also very important as a network engineer. Yes, guys. Okay. If we check the chat box, then all right. So you guys have no questions till now. Okay. All right, guys. If there's no questions, then that's okay. No problem. Now, Mr. Arun will take some time here. Arun, I'm audible.
Yes, sir, you are audible.
Yeah, yeah. You can continue for like. No, I'll stop sharing. Okay. Then we'll see.
Okay, sir. Thank you, sir. Hello, everyone. How is the session going so far?
Going well, Arun.
Great, great, great. Are you enjoying the session?
Absolutely.
Great.
Very well, sir.
So, for those who are eager to extend this enjoyment of having the great session for next 1 month, so we have a good news for them. We are launching our enterprise troubleshooting course, which is starting from 10th of the November, and I will be sharing the detail of this course. Let me share my screen. Is my screen visible? Please confirm.
Yes, now.
Okay, so our CCNP enterprise troubleshooting. This course is starting from 10th of the November. Time is 6 p.m. to 8 p.m. Weekend, weekdays we have both type of batch. So if most of the people will prefer weekdays, then we will be having the session on weekdays or weekend as per the convenience of the students. Okay, let's see the content. So we are having these modules in our troubleshooting course, like introduction to troubleshooting principles, Cisco troubleshooting methodology, and then common troubleshooting strategies. I am Damsel, which sir were discussing Cisco iOS diagnostic tools, interpreting topology and identifying failure points, overview of T-suite network diagram and baseline configs. Then you will have lab. Similarly, we have layer 2 troubleshooting, in which you can check the modules that we are having. Then we will have IP connectivity troubleshooting, all the modules listed under it. Then ERGRP troubleshooting, as sir was discussing, you will be also having routing and switching troubleshooting. So all those modules are listed here. I'll share the link of this page. You can visit here and check. Okay. These kind of scenarios we are going to cover. And if you want to see the feature, you can click on here, show more. So these are the feature of this course. If anyone has any doubt about this course, please ask.
My
Anyone?
quick question is the duration. I see 6 to 8 weeks. Is it 6 weeks or 8 weeks?
Yes, it will be between 6 to 8 weeks.
What will make
Okay.
it just 6? What will push it to 8?
We cannot exactly commit the number of weeks because the weeks might increase if we need more time. Okay, our focus is to deliver the entire content, whatever there is in troubleshooting course.
Okay.
Okay.
All right. So that's why there's that duration, and probably there's also the possibility it could go beyond 8 weeks based on
Right,
how things
right,
go.
right, right.
Okay.
If we need more time, then definitely we will take, but we will not compromise with the content that we are going to share. Okay. It will be entire
Awesome.
troubleshooting, which will help you to troubleshoot the enterprise level network. Okay.
Awesome. So it's only going to be on weekends, right?
Right. Again, it is
Um,
it can be weekdays and weekend both also, but it will depend on the students because many people
okay,
come ask for weekdays, some people ask for weekends.
okay. But currently the schedule is for weekends. And for the weekends,
Yes,
is it just Saturdays or you're
yes,
doing Saturdays?
because most of the people are working professionals, so they don't have time on weekdays.
I understand. I just want to make sure I know what it is. So is it Saturday and Sunday or just Saturday?
No, it is on Saturday and Sunday both.
Okay. And that would be 6 to 8 IST, right?
Right, right.
Okay. I'm asking because of my time zone and all. Thank you.
Is there anyone else who has any question?
It will be more about how to enroll. I'm already in the PM network
Okay,
ecosystem.
so I will share the link of this uh, page in the chat, and also I will share the chat box of PM networking where you can directly message and ask your doubt.
Thank you.
Okay, I have already shared it. Anyone else who has any doubt? Hello.
Yeah. So who will be the instructors? Is it yourself, Aaron,
It will be Amit sir.
Praphul?
Amit sir, who is taking this session.
Okay.
Sir, you can continue now. I think the doubts are
Yeah, we are good
resolved.
to go now. Thank you, Arun.
Okay.
So, yes, guys, if you're interested to join this course, you can visit the link as shared by the Arun Kumar, and you guys are already a part of the WhatsApp group. So, you can reach out to our team for this particular course. Okay, but it is going to be very interesting, as well as you can say very important for network engineers to understand the network fundamentals, so that you guys can start troubleshooting the problem, or you don't feel you can say challenged, right? Because when we go into the network, yes, we know things, but sometimes it is also very important to have a process in hand, or you can say having a cleared or structured approach to solve the network problems. So in this particular series, we are going to start with the headers first. We're going to deep dive into these headers. We're going to understand about all these. Then we'll talk about packet flow, because understanding the packet flow is also very important. And alongside in this packet flow, we'll talk about trace route, how to check the trace route output, how does it works, what is the maximum number of hops you can trace. If you know about Cisco routers, right, they can go up to 30 hops to trace. Then what is the importance of TTL, time to live? So we'll discuss about this packet flow. After that, we'll move to layer 2 switching protocols, because in enterprise network we are using the catalyst switches, and on the catalyst switches we are running spectrum entry protocol and all. If I give you just a simple scenario, let's say if we have this kind of a design, this is a switch number 1, this is a switch number 2, this is a switch number 3. Let's say we have a linear topology. Okay, there's a user, we have multiple VLANs in this environment. Let's say we have VLAN 10, VLAN 10, 20, VLAN 20, 30, 10, 30, 30. This is a network design we have, right? Let's say, and then we are having these interfaces configured as trunk. Now guys, the problem I'm facing is the VLAN 10 users is not able to communicate with this VLAN 10 user. What could be the reason, right? So we'll start finding the reasons here, like, okay, VLAN 10 must be there on switch 1. But when we make the VLAN configuration manually, when we create VLAN configurations or when we create VLANs manually, we'll see, okay, We don't need to create VLAN 20 on Swiss 2. Sometimes we skip it because we see, okay, VLAN 10 is not needed on Swiss 2 because we don't have any active user. But the problem is, if traffic comes from this side with the VLAN 10 tag, Swiss 2 is not going to pass it. Even this simple problem can cause a big issue in the network. VLAN 10 users will not be able to communicate because this Swiss 2 is acting as a transit switch. And if you forget to create VLAN 10 here, if you're using VTP, then it's okay because VTP will synchronize the same database. But if you're making manual VLAN configuration, then it's going to be a challenge. So we're going to see what kind of problems we can have in layer 2 networks. Then we'll move to layer 3 also. In local layer 3, you might be running OSPF protocol, EIGRP protocol, BGP protocol, HSRP, VRRP. There's a lot of protocols we have. Then guys, we'll also talk about wireless as well, because wireless is an entirely different kind of technology, but wireless is very important in enterprise network because we use wired and wireless both. Okay, we use wireless and wired both. So it is going to be very interesting and very informative course, and it is going to help you a lot in your career also, because having this knowledge, even in the interviews, it is asked. They ask a lot of questions from troubleshooting scenarios also. That this is the this is the topology, and this is the configuration, but still the traffic is not going from point A to point B. How you'll find out the problem? And I've seen a lot of questions from the troubleshooting part in interviews. So I wish you the best, and I request you guys to join this session. Okay, either the weekend or weekdays mode, but yes, it is going to be very very informative and helpful for you guys. That's all from my side. Okay, and I'll see you in the class then. Wish you the best. If you guys have any question for me, guys, please feel free to ask. Yes, recording will be available. You guys will get the recordings. So we'll have classes, then the recording will be shared later. So need data center Nexus, Cisco 9K VDC. So need data center Nexus, Cisco 9K VDC, VPC, VXLAN. For that, we are launching a CCNP data center batch. You can join that, Guru Swami. Okay. Going to start a data center batch in weekdays. So in that data center batch, we cover these technologies: Nexus, 9K, VDC is supported on 7000 series, and 7000 series is not now. It is end of life, end of sale. But yeah, VDC is a very interesting concept. We can talk about it. Then VPC and VXLAN. So all these are part of CCNP data center. We are launching a batch soon. Yes, guys. Any other question here? When batch is starting, sir? So if it is weekdays, then we'll be starting it from Mondays, and if it's going to be weekends, then we're going to start it from 8th of November. So it depends on you guys, right? Once the majority of you guys will prefer, we'll start with that, either weekdays or weekend. Okay, you're talking about CCNP data center or this troubleshooting batch? For the data center batch, you can reach out to Arun. Okay, he'll give you the details.
So data center batch, you only taking the instructor like me, sir, or
Yeah, I'm taking that batch.
okay. So it is like a weekend. The duration is 1 month or 2 months, like weekdays.
It's
If it is weekdays.
2 to 3 months. Actually, it's a data center, so it is a detailed course. Okay.
Okay. Okay.
Yeah.
Fine. Thank you, sir.
You're welcome. Yes, troubleshooting batch starting from next weekend. Yes. Uh, the timing and the details will be shared by Arun. If it is weekdays, then it is going to be start from the next coming Saturday, and if it is weekdays, then it is going to be start from 10th of November. So we'll decide it on the behalf of the you guys. but our majority of you guys will agree. Accordingly, we'll define it. Okay, we'll plan the batch.
Those who are having any doubt, I have dropped the chat box link of WhatsApp number of PM networking, so they can contact out on that number.
Yeah, guys. Thank you, Arun. Yeah. All right, guys. Then have a good evening. Thank you for joining this session. Thank you for giving your valuable time on weekends. Okay. Have a good evening.
Thank you, sir, for doing.
You're welcome. You're welcome, guys.
Thank you so much.
You're welcome. Yeah.
Quickly, when is the deadline for registration for the enterprise troubleshooting?